Thank you very much, and welcome everyone to today's event. Like it was mentioned, my name is Gina Colazo. I'm an industrial organizational psychologist, and I've been working in the pharmaceutical and medical devices and GMP-related environments or manufacturing facilities most of my career. 9 years ago, we established a consulting firm on working on human error and basically solutions. And the reason we did this is because we noticed that there was a huge gap in terms of addressing human error in the manufacturing floor, and it was not necessarily being addressed. And we noticed that need was there. But let me tell you a little bit about where all of this comes from. Like I mentioned, I worked in the industry. I held positions as a training specialist, training supervisor, training manager, training director, all the way up to being a training and human reliability director, which was my last job after I decided to join the consulting industry. So what I'm trying to say is that what you're going to hear today is something that was born and raised inside the organization and not something that was created in a book outside without considering all the realities and all the conditions that are so particular to a manufacturing environment. So what I'm trying to say is that what we did was that we were looking for answers. And the reason we were looking for answers is because we were questioned in terms of training. You know, we keep doing retraining and retraining and retraining, and it's not working. So the training program needs to change. Something needs to be improved. And in that particular experience, the training program did not have any problems. So I remember asking, I'd say, no, I don't think it's training, but then I was challenged. If it's not training, then what is it? And this is where it all started. So that's where we started looking for answers to make sure that we would address not training-related situations, but basically human reliability situations. And that's why we started to expand a little bit our scope of understanding this phenomenon. So that's the background of how we got here, and I like to tell or share that because I can tell you it works because I've used it, and my neck was on the line because I was not a consultant. I needed to be there for the KPIs and my evaluation. So what I'm trying to say is that I already made all those mistakes, so we know now what works and what doesn't. So why talk about human error? Well, there are many reasons. First of all, it is a regulatory requirement, and we'll get there in a minute. But if we look at the big scheme of things, it is the major contributor for non-conformances, for defects, for unplanned downtime. It impacts our metrics, OEE, cycle time, schedule adherence, customer service, all of it. So we do know that it is a problem. It impacts safety, quality, and the business. And we need to do something about it because every day that passes, you have another new technology coming out, and we advance so much in terms of technology that all we are left is with those hands that we cannot automate, those eyes that we cannot automate. And that's why we have to take a look at the equipment, meaning human equipment and not mechanical equipment. So yes, we need to talk about human error. Like I mentioned, it is also a requirement from the agency, and it's established, and we'll see it in a minute in the regulation. So human error and training, I started talking about training. Well, there is a good relationship here because human error usually triggers a retraining. If it doesn't, then maybe a procedural change or something like that. Those are the top two hits for corrective actions and preventive actions for human error. So yes, training is very good, and training is something that can really help. But basically, when we use training, we use it as a vaccine for mistakes. It's what you do before you assign people to execute independently, and before we trust people to execute and touch the product, right? So we do it before we release for independent performance. It is effective to transfer knowledge, skills, and ability. So if it's not related, if the people have the knowledge, have the skill, and have the abilities, then training is already done. So it's good for new employees, new set of knowledge, skills, or abilities for new processes, new equipment, new technologies, for changes. But data shows that less than 10% of human error events are related to a lack of knowledge, skill, or ability, meaning related to training. So what we have noticed after learning this is that we were putting most of our efforts in 10% of our problems. And that's why we said, well, there is a huge gap between training, one solution, and the solution of the problem. Because if I say training, but training is 10%, where is the other 90 if I'm not doing anything else? Well, the other 90 is what we call the missing link, and that's the part that what we want to share. And that's the part that we had to look for information and create a methodology, which is what you're going to be seeing today. All right, so what does the regulation say? Why do I say it's a requirement? Because it is. It is, and I'm just going to show you two examples, but if we look through most of GMP regulatory bodies around the world, they all have basically the same requirements, or at least the same expectations. So it's not something too far, if we go through all of them, then of course we'll spend a lot of time. So I wanted to choose two examples. So I chose 211, right, for finished products. And in 211.22, it talks about the responsibilities of the quality control unit. Of course, we have to have a quality control unit, and that quality control unit has the responsibility and authority to approve, reject all components, and so on. And it has the authority to review production records to assure that no errors have occurred, or if errors have occurred, that they have been fully investigated, meaning that we found the root cause of the error. Well, that means that, yes, you have to have an investigation program for human error because they want you to fully investigate the human error. So human error is not a root cause. Human error is a causal factor, and that's why we have not been finishing our process of doing investigation. So that being said, if DA is telling me if there is a human error, I want you to do a root cause analysis and investigate it, right? But then Europe was a little bit more specific and say, I understand that you already were told by the FDA on the expectations, but I want to give you a little bit more of details of what we expect. And there in the European GMP says, where human error is suspected or identified as the cause, meaning causal factor, this should be justified having taken care to ensure that process, procedural, or system-based errors or problems have not been overlooked if present. Appropriate corrective actions and/or preventive actions should be identified and taken in response to investigations, and the effectiveness of such actions should be monitored and assessed in line with quality risk management principles. So what we see here is the expectation, but not only an industry standard or an expectation is written. It's directly saying, I want you to evaluate, I want you to do a full investigation, and that you don't ignore process, procedural, or system-based issues. And that's why we want, and then on top of that, we have to make sure that we justify it, that it makes sense, that when you explain that this was a memory failure because there was an interruption, oh, okay, that makes sense. And we'll get to it. But the important thing is that when you explain, we had a deviation and we retrained everybody. Well, yeah, well, that's what we see, but why? Why training? What was the lack of knowledge or skill or ability that you were looking to satisfy in order to increase that human reliability? Well, we don't know because they do have the knowledge, the skills, and abilities because they've been trained before. People have done this activity before, so that's why there is a lot more interest. We have been inspired by the regulatory agencies to look further, and it's becoming very apparent that there is a lot of push to make sure that we avoid human error as a root cause, because human error is not a root cause by definition. All right, it's a causal factor. It's basically the concept of all of this. So let's understand a little bit about humans before we start talking about the methodologies that I want to share with you. First of all, we have to understand that the human equipment needs to be understood just the same way as we try to understand equipment behavior. We have a lot of engineers that can that can explain equipment behavior. We have a lot of experts that can explain product behavior, process behavior, all of these things. But we don't have any expert that can tell us, explain the behavior of the most complex equipment in existence, which is the human. And I do compare it to equipment because we're very nice to our equipment, not that nice to people, because we provide everything, IQ, OQ, PQ, GQ, everything Q. Then you have, predictive maintenance, preventive maintenance, troubleshooting, shutdowns, all of these things, so qualification, all of these things that we really take care of the equipment. So yes, errors are going to happen because we're human. So human performance, yes, to err is human, but to forgive is a good design. Why? Because, yes, we can avoid human error by having good designs, just like Europe asked us in terms of identifying process, procedural, or system-based situations. So, yes, I think we agree on that. So some facts about human error and other industries. For example, the Center for Chemical and Process Safety, which is a division of the American Institute for Chemical Engineers, they have some guidelines for investigating chemical process incidents. And one of the things that they establish with certainty is that, yes, 90% of accidental losses, except for natural disasters, begin with a human error. Now, root causes of these accidents rely or are related to management weaknesses. So basically what they're saying, yes, people make mistakes because they can, because our systems allow it. And that's kind of worrisome because we are supposed to have very robust systems. System-based inspection, look at my system, look at all these checks, look at all these barriers of defense. But then after all of that, and we are very impressed with the robustness of all of our systems, we get asked for a list of investigations and then top of the line human error. So how robust can your systems be if your people can break them so easily? We have to challenge these things, and it's because of this, because we have not been deep diving and understanding what is causing people to not pay attention in particular moments, or to forget things, or to do things improperly, or in a different way than expected. So that's why we want to do a deep dive and take a look at this piece of information. That is not that we have been doing it incorrectly. It's just that we stopped the investigation where it should begin, and that's why we know that that we have to have a human error investigation process as part of the whole thing, and it needs to be like that because I need to find out the root cause of the mistake, and our systems usually don't provide us with that information. All right. So that being said, we do know that the systems are basically responsible, those are very good news, because that means that we have control of the solution. When you are part of the problem, you're part of the solution, right? So the first thing that I want to start changing in terms of our beliefs of human error is that we have to change the vision and move towards modern, more data-based conclusions, okay? So the old vision says that human error is the cause of accidents, incidents, and everything. So it's people, that come in and break everything. Everything was perfect if it wasn't for these people. And then in order to be able to explain it, you must find in employees inaccurate assessments, wrong decisions, bad judgment. That was the past. The new vision says, wait a minute. Human error is a problem deeper inside a system. It's a symptom. And there is something that we should identify that is allowing this situation to happen. Remember, in the workplace, we are in a controlled environment, so we can actually control everything around us. So at the end of the day, we could achieve very good human error rates, but we have to do it by understanding that it is a symptom, and instead of trying to find employees inaccurate assessments, wrong judgment, bad decisions, you want to understand how employees' assessments and actions made sense at the time given the circumstances that surrounded them. So one thing that I want to say is that people might break the rules and will break the rules, but people break the rules when the rules don't make sense to them. And that's one of the things that we need to understand how it makes sense to you to make this decision. So I can understand where is the thinking process gap or lack of information that I can provide you so you can understand and make better decisions after the fact. So there is a lot more to it. It's like what motivated you to do certain things, and those things are part of our quest for answers. So why? Well, people don't wake up in the morning saying, yay, today is the day that I'm going to make a mistake. That was my goal. I'm very happy. I got in trouble. No. We know that people want to do a good job. People want to be successful. And if something happens and there is some harm intended, then that's not a mistake. That's not an error. An error will be that the sabotage is planned and it doesn't work. But if it works and there was harm intended, there is no mistake there. And I want to get that out of the play because I think that that's the reason why we think on discipline immediately. It's like you were not paying attention. You were doing this wrong, or, you wanted to do things like this. Well, I don't want to get in trouble. What makes you come into the conclusion? So there is something more that we need to understand in terms of the thinking process so we can provide with that information, whatever it is and wherever it needs to be shared, meaning training or procedures or so on. All right. So, for example, I want to do a quick exercise here. I want you to, now that you have this slide over here, I want you to count how many F's, as in fabulous or fortune, are in this paragraph. I'm going to give you 5 seconds, and you can count how many F's. Okay, so if I ask you how many, of course I don't have you here with me, but I usually get responses like 3, 4, 5. Then I say, let's do it again, because people get different counts on the same thing. It's our way of identifying these defects over here. Let's say that the F's are defects. So we can try it again. Let's give you 5 seconds again so you can count again. And if you did not get to see 6, well, then you did not detect all of them. And the six, let me change the color here very quickly. So the 6 F's are here, and the offs, of course. Okay, I wanted to highlight this here and here. All right. Most of the time, people miss the offs, and that's something that is very natural because of the way we process the reading in our brain, the way we read, which is basically by pictures, the lack of meaning that makes our brain to ignore it. There are many reasons why this happens. So what I'm trying to say is that mistakes are part of our nature because we are wired that way, and that's how we survive, because we have to we use what we have, the skills that we have acquired, and we don't even know that we're doing it. In the previous example, if I was to help you be successful in that activity, then probably I could have presented the colors so I can highlight it, and then you'll be successful. So those are the kinds of things that I like to share. I don't know how much we could get from a distance in an exercise like that, but what I'm trying to say is that our brains, and we all make mistakes, and we are wired in a way that it could happen, and that's why we have to put barriers of defense in our processes. So again, performance is affected by many things, not just one variable. Okay, human performance is affected by internal factors, biophysical factors. External factors, things, equipment, noise, illumination, all of these external things to me, they're consuming some resources of attention and cognition. The systems that I have to follow, of course, affect human performance. And then the capability, how much I can do. There's so much I can do. There's certain things that I won't be able to do. For example, multitasking. I won't be able to multitask because humans can't multitask. I can do a few activities in that period of time, but it's going to be linear because I can't do two things at the same time. So that's not multitasking. It's basically a linear line of activities. So we have to be very careful because sometimes our expectations are not realistic on the nature of what we are trying to address. So human factors and that capability is something that we need to learn in order to be able to put barriers of defense and avoid certain type of issues or mistakes. Okay, now we're ready. Now that we know that people will make mistakes, there are different type of things that affect in terms of cognition, and we'll talk about them in a minute. But once we have we already suspect that there is a human error, like Europe says. Once you suspect, well, we already have a suspicion that it's human error. This will be the first step that I want you to take. It's very revealing in terms of the information that we get just by understanding the type of error. It will guide our quest for answers because again, it's a manifestation of something deeper inside a system. So I need to understand how that phenomena manifested and what was the type of mistake, so I can then put my quest for answers in those directions. For example, there are 4 types of errors. We have intentional errors of omission, intentional errors of commission, unintentional errors of omission, and unintentional errors of commission. So action, commission, lack of action, omission, and then the psychology behind it. If I wanted to take this step and it was a decision, or if it was something absolutely unintentional. I want to clarify again that when we talk about intentional, we're talking about people wanting to do the best thing, help in the process with good intentions, meaning I wanted to save time, or I wanted to be faster, or I wanted to there are so many reasons why people might make these decisions, but what I'm trying to say is that this is the moment in when somebody decides to, you know what, I'm not going to do that step because cycle time reduction, OEE, is green, it's starting to, it's yellow, so I have to make sure it comes down to green. And all of these things are motivators from the environment that are guiding my behavior. So in this case, it's like, forget it, I'm not going to do that step. Why? Because that step does not make sense to me. So I'm going to skip it. And then all of a sudden something happens. Or I did a little bit more or less, meaning it was 85 degrees and I have to mix for 5 minutes, so I'm going to increase the temperature to 87 and I'm going to do it in 4. Those are the kinds of things that happen when people are trying to survive in an environment when there are so many challenges, considering, and here we need to understand what happened so we can guide, again, our investigation towards that line. So if I know that you are trying to do this to save time, I need to know what's happening. And then when I talk to people, well, you know what happened? Planning did not have the caps. So it was delayed, the batch. And then all of a sudden we have to finish because they are calling that we have to finish so we can send it because they're waiting for it. So there are many motivations, like to do more with less steps. So we have to be careful that there are messages that are guiding behavior that we are not aware that we are giving, even though it's not our intention. And sometimes we are so passionate about certain messages, but then not that passionate about others. For example, productivity versus quality. And then sometimes I'm gonna make a decision based on what I think is more important to you, or based on the metric. If the metric is to finish on time, then I'm going to finish on time, because the metric is not to be able to release, so I don't care. As long as I finish on time, we're good. So, of course, this is not something that is happening necessarily in consciously, but there is an analysis here. Then we have an unintentional mistake, which is I forgot, memory failure, attention failure. I chose the incorrect grease for my equipment. So in these cases, it's something that happens to me. I cannot train and provide you with more attention resources or more memory resources. When we have an unintentional error, it's something that happened to me. So I have to evaluate what type of controls do I have that is allowing memory failures to create deviations. So here is where I need to evaluate external efforts and look for other things like attention-grabbing methods or features or other things, checklists, alarms, feedback from the system, something that will trigger that I have to either pick up the sample or have to document, whatever it is that that we don't want people to forget. On the intentional portion, certainly there is a lack of information and some knowledge, meaning the whys. So we have to provide that information, whether it's part of our training or whether it's stated in a procedure, in a warning or a caution, meaning, this step, you can't skip this step because this is the risk of contamination, risk of whatever it is that can cause the defect. Not a deviation, because we all know that if we deviate, we're going to have it independently if it has an impact in the quality or not. We are going to investigate just in case. But when we're talking about providing the whys and providing those cautions or warnings, is because these are those critical steps that can make or break the process, that will have an impact to the point of maybe creating a situation in which I have to dispose the batch and not be able to release it. All right? So that's why once you know what happened, you say, was it intentional or unintentional? Well, it was intentional. Okay, so let's see what is motivating. Or it was unintentional, the person forgot. Well, then what we can do to remind that is, provided that is something that requires a whole change. Remember, we're not going to do change or create norms for exceptions. But this is the level of analysis. So the first time is intentional or unintentional. And then we continue with the quest for answers. If it was a lack of knowledge, lack of skill or lack of ability, now we know it's training. But if it's not that, then we have to continue. So common causes for errors, and either intentional or intentional, could be memory failures, which is the multitasking, which we just discussed, hurry, stress, meaning that if you have too much, you're hysterical, and if you have too little, you're bored. So you have to have the right amount of stress so you can increase the level of situation awareness that then elevates my attention. So that's why these are all causes for this. Overconfidence, we really think that we are better than we are. This is what's supposed to happen. That's self-esteem, and that's okay. But the reality is that at some point we get so comfortable that we really think that we are good to go without procedure, without a GPS, without whatever it is that guides us, and we say, we can do this without the procedure, or I can keep this step. So that's why we need calibration. Humans are elastic. We need to make sure that we put you back online and say, where's your procedure? Where is your gowning? Why are you documented that now, and why didn't you take your map to your line clearance? These are things, because you can do a lot of things, but if we don't enforce the systems and the process that we have put in place, then we can't expect any kind of changing behavior. Then we have the visual detection, and then the hearing and all of these senses. We have, in terms of visual detection, we're very bad after 1 hour. We don't even see anymore. So that's why we have to be very careful. I slice to you. You see things that are not there, and you miss F's that were right there. And those are all things that we need to understand. So this can cause errors related to confusion, memory, and bad decisions as well. So now we have conditions that put motivation in me to do certain things in a particular way, because I think this is going to have a successful outcome. And that's what we need to calibrate, that false belief that everything is going to be okay and nothing is going to happen because it's me. Right? So, like I was mentioning, we wanted to address all of these situations, so we looked at other industries that were doing this in a serious way, and I say this with a lot of transparency here, because we were basically trying to fix the blame, but we needed to fix the problem. And these people decided at some point, you know what, I'm going to fix the problem. So we looked and we learned a lot from other industries, especially the Nuclear Regulatory Commission, which has a lot of very valuable information in terms of human reliability and metrics and statistics and so on. So what we did was, let's see what's out there. and let's look at the best practices that we see in other, not in our industries or in other manufacturing facilities, not in the world. What are we doing? And then we started looking, and we found a lot of information then translated into this methodology. For example, this is one of the data that you can get if you wanted to from other industries. In this case, this is a Nuclear Regulatory Commission CR 1278, and this table is basically telling you the probabilities. This is estimated human error probabilities for errors of commission in reading and recording quantitative information from unannunciated displays. Okay? So what it says, if the person is going to be reading and recording from an analog meter, the likelihood or the probability is 0.003. If it's a digital readout, less than 4 digits, it's 0.001, which is the lowest observable in terms of impact. You can get 0.00001, but that would be negligible, and we don't measure more than that. 0.001 tends to be the lowest observable rate in pilots, and that's a good way to compare ourselves. Printing recorder with large number of parameters, 0.05, graphs, and so on. So what you see is that there is data, there is science that tells us sometimes you have to change the way you're doing things, because if you have a chart recorder and you want, and this is so critical, let's change it because we know it's going to come down. The probabilities are less if we have an analog meter or a digital readout. These are those things, because we cannot change human condition, but we can change the conditions in which humans work. And that's why we have to gather this knowledge, because we don't have this type of knowledge inside the industry. This is just something to compare. This is another example. In this case, what we are seeing is the number of possibilities of mistakes or failure for each annunciator for completely dependent set of annunciators successively addressed by the operator. So if we have one person and one alarm, then 0.0001, which is great. The likelihood of making a mistake is almost none. But then if you have two with one operator, then it's going to continuously increase until you can have 10 alarms going at the same time, and it can go all the way up to 0.25. There are other elements here in the calculation, but it's just to illustrate the human reliability degrades by the level of stimuli and multiple stimuli at the same time. Okay, so humans will make mistakes, so let's clarify expectations. It's part of our nature, so don't expect to have 0 deviations due to human error. Even though we could, I know that we could, you won't, and there is a reason, and I'll explain in a minute. We can, but you can have 0 major deviations due to human error, okay? So you can say, I know that I will have errors, but I want to keep them where I can control the magnitude of the consequences, where I still can detect them and recover from them. So that means that you want to get them as early as possible, but today we don't investigate notification of events, so we have to wait until it's a deviation. That's why you won't get to 0. If you were to identify this at the notification of event level, where it's not a deviation, because it's not, and that's why we are addressing it and documenting it, and we know what happened, but you already know that there is a weakness in the system there. So since we don't assign corrective actions for those, then we have to wait until it becomes a deviation so we can now analyze it. But if we were to create levels, then of course, you grab them where you still can control the magnitude, and then you can say we had 0 major deviations, and that's provided you have different levels of investigation. I don't have a problem with it, but what I'm trying to say is that it's very unlikely that you will take action in a similar way as safety with near misses, because we don't do that in quality, which is a problem, because we have to wait until it fails to be able to address it. All right? It's like saying, give me the near miss, but I'm not going to do anything about it. Okay, thank you for the information. That doesn't work like that. All right? So But things can be done, of course. A lot of things can be done, and we have been very successful. So I can assure you, if you take some of these tools, you'll see a difference, okay? And you don't need me for that. It's right here. That's why you're here learning. So some things can be done. 80% of the success relies in human factors in work design, and you'll see a tool that is directly related to this 80%. So what we're saying is we want to, again, change the conditions in which humans work. That's the best part, the very beginning. Now that you change everything in your control, then you can move towards behavior-based and individuals approaches. Okay, so the first thing you want to do is try to predict. How do we predict? I'll show you a tool to predict, and also you already have data that allows you to predict. We use past data, past investigations, submitted to this process, categorize and code them, and now we know that if we don't do anything about this, it's going to repeat itself. There's no better predictor for the future than the past. And that's why we collect data, right, to be able to predict what could happen if we don't do anything so we can understand how it's behaving. So we predict. Then we determine if we want to prevent the error or if we want to incorporate a barrier of defense, because not everything requires prevention. We don't want to be shooting mosquitoes with cannons. You know, it's a good use of your resources, and sometimes prevention requires automation and a lot of money. So we have to evaluate based on risks. Okay, so I want to detect it because we can correct it instead of implementing all of these electronic things that really don't have that much of an impact. So, or the problem is the solution is way too big for the problem. Or you want to detect so you can correct and recover. So these are the things that we can do, prevention all the way to recovery. And all of these things are going to be part of your assessment of the situation. Okay, so let's take a look at the model. First of all, you would need, and this is something that is very important because when you address individual investigation, it's gonna come up with you are gonna end up with a root cause code. So we are going to quantify how many of these events or root causes have been discovered. So my recommendation is that you start with a pre-measure, which will be the human error rate, the baseline, the first one. You have never measured it before, well, then now you're going to start. So since we don't know what we don't know, we look for how many non-conformances related to human error, right? The formula is the generic. No, don't look at this one, generic. How many errors divided by how many opportunities to commit them. So it's non-conformances, batches. Tests, non-confirmed OOS, which could be analyst error, divided by how many tests I performed. That's how we want to see it. We want to see it in a ratio because it is related to opportunities to commit them, to actions. For example, 2 documentation errors divided by 16,500 entries, and then you do the calculation, and then you can go back to the Nuclear Regulatory Commission or FAA and compare your human error rate, and you'll see that you are very, very lucky because it's almost impossible from a human standpoint that after those many opportunities there won't be a typo or something written incorrectly because of the magnitude of the data that we have there, not because of it's likelihood. So you want to have this. Let's say you have, 50 deviations related to human error, and then now you have, and you manufactured 100 batches. Well, then it's 50% human error rate. That's impossible. So I use that in ridiculous example. But that way you know where you are today, and that becomes the baseline. And that's where you're going to start measuring your improvements and see how it behaves month after month. So what are the process? Well, like I mentioned, you need data for this. So you either start today and start gathering this data or go back to your past and do a diagnostic assessment, collect 12 months of human error deviations, previous human error deviations, categorize and code them using the tool that we are going to learn today, and now you have the distribution of the numbers of your problems and your human error rate. Now, then, after that, of course, you want to do training on investigators and so on. This is what we do when we do consulting. But it's the process that we follow. But what I wanted to highlight here is that you can do your own diagnostic assessment, but you have to go back and try to match it with what we have today. And then continue with other assessments that will give you more data, implement changes, cultural change process. Here is where we start with the 20%, and then monitor and train because you will have your codes. So that's basically how the process works. So this human error reduction model is based on three main concepts, which is the management systems, and NIA, Center for Chemical and Process Systems, told me, but also Europe says system-based, right? So I need to make sure that I'm addressing those. Human performance, which is related to human factors, and here is where procedures and process and all of that falls, just like Europe was requesting. And then individual performance, which is specific to a particular person or a particular group, or more into culture. It's basically excluding any control that I have in operation, and it's more human-based, okay? So these are the three main components, and we're going to see how it looks. So this will be the investigation framework. And I know it's a lot of information, and you'll see how it all comes back into place, and it will make a lot more sense. But based on the information that we have, what we want to do is make sure that we identify the root causes for the mistake, right? So based on that information, we created this framework. It's based on the 5 whys, right? We start from the very moment we suspect or we already know that it's human error. That's my first causal factor, okay? So it is human error, the first thing that I do, because now I'm starting another investigation, the human error investigation, not the event. I already know that the event, one of the causal factors for the event was the human interaction. So now I have to investigate another thing, which is the action of the person, because we already know that. So now what I want to make sure is that I fix this so this person does not do this again, because that caused that deviation. Okay, so it's another why. I always say, this another why, and we start again, 6 why. So that would be the causal factor, human error, number 1. Then I need to understand what happened, so it's either a system problem or a human performance problem, meaning either the system was weak and put me in a situation to make a mistake, or it was an actual action from me, in which case I need to understand the root cause of those things that have an impact in my particular behavior, meaning procedures, training, human factors engineering, layouts, all of these things. And then there is the part where individuals are incorporated in the level, the depth of investigation. So causal factor, why number 1, human error, problem type, why number 2, cause category, why number 3, then we have the near root causes that go in between these two, and then we end up with the root causes, which is the why number 5. And this is how we do it. I'm going to give you an example of what could be a system problem. Let's say we had a deviation because we used the wrong cap, right? When we were doing the investigation, what we noticed was that the reason why we used the wrong material was because we requested the wrong one. And why we requested the wrong one? Because I was following an obsolete version of the procedure, and it already changed. And I did not know because the procedure I'm using is obsolete. Now, in this case, I would categorize this as a management system situation. Why? Because we have a documentation and configuration control system that is supposed to control documents, and obsolete versions of procedures should not be available for their use. So we need to understand where is the weakness, where is it, how is it that little guy escaped, because we need to make sure that we prevent this from happening again. Because it's another thing that the person in manufacturing has to address, and then of course a lot more information goes in my cognition, and then my cognition is compromised, and then I forget or miss things that I should have done. And then, so that will be a management system. A human performance problem would be something that I did. No, the person actually chose the incorrect action here, or followed the wrong sequence, or so on. Okay, so And then based on those, then is that we are going to use the tools, the root cause determination or cognitive load, and we'll talk about this in a minute. Just wanted to let you know how is that framework is created. All right, so let's take a look at the process. The system problems that in this category, in this problem type, these are the categories that we have. We have investigations, documentation, risk assessment, material handlers, suppliers, validation. We also have policies and facilities. This is just examples, but you're going to have the whole list in the tool. These are the systems that we're talking about. And remember that we keep saying that our systems are very robust. We have to be very careful. So we want to see if for example, we had a situation and we investigated it and we established the root cause and we put in place the corrective action to be implemented, but then before it's implemented, it happens again. Then we already think we know the root cause, but the reality is that the root cause of this one is because you have not implemented it yet. So maybe the time that we are allowing for it to be implemented is too much and is allowing this situation to repeat because we already know this is what's happening. So attributed to the same root cause is basically saying the same thing. So basically you have to take a look and say maybe, and again, everything is going to be analyzed based on their own merits, of course. Okay, so this is just to give you an idea. Then we have the human performance, which is the human factors portion, which is procedures, human factors engineering, training, supervision, communication, and individual performance. And then we have individual performance. Let me see if I have here. Okay, in individual performance, we also created what we call a subcategory, which is cognitive load, because individual performance issues happen because of cognitive load, and we deep dive on those. So what are individual performance near root causes? Well, slips, mistakes, and violation. So slips are things that are unintentional action. It's the first time that it happens. We don't have any explanation. It's something that just happened, period. Those we cannot predict, prevent. Those are the 0.001 of the pilots, right? So if we want to avoid those, we need to eliminate human interaction. We have to eliminate the person. We know that there are some points, it could be a slip. Then we have mistakes, which is thinking process. I made a bad decision. Is error in your thinking process, in your judgment, and most likely because of a lack of information or the whys and so on. And then we have violation, which is a repeated event. Consequences were known. You were just trying to get away with it, and but we already know that. And before we get here, we want to do the analysis to eliminate everything else because we want to be very fair, and we're looking for the truth to fix the problem and not the blame. So that's why let's take a look and let's see. Now, if all of a sudden you see that there is a lot of memory failures and attention failures and violation, then we have to deep dive. Then we need to look a little closer in the process, and that's where we activate it, and that's how I say it, right? This subcategory, which is cognitive load, that we'll discuss close to the end of the event. All right, so that being said, then here we have the categories. So with cognitive load, we did something similar to the root cause determination tool and identify the categories. And the categories on cognitive load are 10 that come from the very moment you start executing and the time you are expected to finish your activity. Not the time you have, the time you're expected to finish. The stress, complexity, instructions, fitness for duty or fatigue, all of these things have an impact in cognition, and this is something that we got from studies from Nuclear Regulatory Commission, and we translated this into a methodology so we can also take a look at our systems, and let's see how it looks later. So this is the tool that we use for, not for cognitive load, these are two main tools, okay? It's the root cause determination, which is this one, and then cognitive load tool. I don't expect you to see it because it's very small. You have an attachment with this. You can print it out and take a look. It's kind of self-explanatory because it's very simple. There are a few things that could be confusing, but you can go through it. But what I want to share about this tool is that it's the best thing that ever happened to us. This is the best discovery because this tool has every single root cause related to human error that you can find. I've been using it for many, many years, and all of them are here unless it was not a deviation, which is sometimes could happen. Because if you don't find it, then there is no deviation, and things like that can be discovered as well. So this tool was originally developed by the Department of Energy of the United States a long time ago, and it has been adapted to different industries, to different scenarios. There is one for maritime. There is another one for refineries, depending on the nature of the activity. So what we did was adapt it the same way that other industries have adapted it to one that will fit in our environment with the expectations of Europe and GMPs and FDA and so on, because we have some requirements that they don't. And when I say they, I say safety because I sometimes we don't understand that it's basically the same thing with a different type of events, okay? So it's basically the same thing. You're dealing with humans and behavior-based actions and thinking process and bad decisions, wrong judgments, and so on, because we're human. That's what we do. We get in trouble. So what I want to share about this tool is that this is the tool that is going to give you most of your data. And I'm going to start from the very beginning. So how do we use this tool? Well, you write human error over here, because human error is your causal factor. If it was equipment, you will write equipment right here, but it's not equipment. So this first problem type that you can see here is problem type is equipment. We are not going to take a look because we are dealing only with B and C, which is systems and human performance problem. But I'm not going to show you the content, okay? I'm just showing you the structure. So we start with the causal factor here, then which is the first Y. Then the second Y will be the problem type. Then the third Y will be the cause categories, all of these cause categories. Then the near root cause is everything that is in bold, okay? And everything that has a number is the root causes, okay? So you'll end up with a code that starts from the very beginning with administrative systems or human performance problem, which is B and C, all the way down to your conclusion. And let me just zoom it so we can take a look in a better way. Okay, so let's say that this is what happened. I was executing, I was working, I took my procedure, I was getting ready for my next step. And the next step, when I read it, says make sure valve 15 is in the open position. So that's my instruction. Make sure valve 15 is in the open position. So I walk towards the valve, and once I get there, I notice that the valve is closed. What do I do? Some people will open it. Some other people say, I don't know, because it seems like it's supposed to be open before, because my job was to make sure. So now I have to figure it out myself. It's a knowledge-based decision, or I can ask somebody, or but it comes to the point where you have to make a decision, and here's where we can make very bad decisions. So I need that information. And let's say that we, after analyzing the situation, we decide that we want that information to be in the procedure because it happens. So we don't want you to open it again out of sequence. It has happened before. Let's do something. Let's include that if it's close, you have to call the supervisor. Whatever, let's say that's the conclusion. So that's why we come to the root cause determination. Even though it can help you do analysis, this is a determination tool. So you say, was it a human performance problem? Yes, so it is a C. Was it training? No, but then it's not C. But let's say that it's let's say that it was training, just for the sake of the exercise. So human performance, yes. The person did not know what to do, yes. So lack of knowledge, so it's training. Why the person did not know? Well, because we failed to train on abnormal events or non-routine situations and so on. So they didn't know what to do in that circumstance. I can say, well, we're going to address it with training. So in this case, it will be training. C6C, which is training, 1-1. That will be my code. If it's procedures, then I can say C4, and depending on the code, I will end up with a root cause code, C4, C06. or see. It's the idea is to code it so we can now track and trend because we need quantitative data and we need to see how it manifests. And then you see category number 9 over here would be C9. And then in this case, we only have near root causes because the root causes are in the cognitive load tool, okay? So in this case, we only have this. So if it's a slip, and we're not going to do something about it, it's a simple thing. It has never happened. Data is recoverable. So it's just a slip. I'm not going to do any corrective action or preventive action. So then it will be C9A00 because I have A. Now I don't know why you made the slip because I would need to do a cognitive load assessment, but probably doing a cognitive load assessment now, it's not worth our time because of the likelihood or the criticality and so on. So that's where we start the conversations and decide if we're going to deep dive. If we say, no, you know what, this keeps happening, I want to deep dive, then of course I will then activate my cognitive load tool. So once I have this data, now I can take a look at my environment and say, this is what's happening. Look, 43%, let's say 43% is related to well, in this case, 43% is related to human error, okay? Then we have 30% that is related to system, and then some things that were related to a software or whatever, okay? So now I know how it's distributed. I'm going to start working with the human performance problem, and then we address systems later. That's what you can decide. Right? So now you want to, but what about people? Perfect. So let's take a look. Now I can say what happened. Well, let's say that that I wanted to address human performance problems. Let's say that 24% of it has to do with communication. People are getting a lot of mistakes because of the communication between the laboratory and I don't know. There are things that are related to between shifts or whatever the reason is, or procedures. This one, let's say then let's say this is procedures. So now I know that I have all these that are major contributors. So I do want to address them. I'm going to take my biggest chunks because I want to see improvement as soon as possible. So let's say I'm going to tackle first procedures. What about procedures? Then I will have to see what events constitute these 24%. So I continue, since I have a code, it will tell me, well, look, the procedure was not used. That's the main reason. That way I say, okay, so why is it that people are not using their procedures? Then I can go to my chart and then see why is it that they're not following it, or go to my root cause codes and see this is the reason why people are not following the procedures, because it's too cumbersome. People don't have the time to do 30 clicks to get to it. I'm just again inventing this example. So you will see where your problems are, so you can actually follow the problem, and you can, of course, create your solution. And that's why we call ourselves human error solutions, because that's what we want. We don't want to create problems. We need solutions. And let me tell you, there is a lot of people that will bring a problem to your solution, so you be careful to that also. So let's say that a lot of people are forgetting, and we're getting a lot of codes on C9, which is individual performance. We need to know what is making people forget. We need to know what's happening there. And here is where we activate the cognition part, okay? So cognitive load. What is cognition? Well, cognition is the process by which the sensory input is transformed, reduced, elaborated, stored, recovered, and then used. Okay, so everything that I see, hear, feel, smell, all of that goes into my brain, and I have to process it. I have so much capacity, and cognition is not that much of a, it's not on, it has its limitation. So in science, cognition is the mental processing that includes the attention of working memory, comprehending and producing language, calculating, reasoning, problem solving, and decision making. So now we know that it's probable that there was a cognitive overload that made me make this decision. I don't even know why I decided to do that. It was caught up in the moment, so whatever that is. And let me tell you, it does affect a lot of people. Sometimes say these like it's something very abnormal, but yes, when you're driving and you have to I don't know, pay a toll or something, and you have to interrupt. A lot of people say I have to turn down my radio, and and we laugh about what does it have to do. Well, yes, your cognition is compromised and it's making you uncomfortable. I need my attention, and the music or whatever it is unconsciously distracting. It's something that we cannot control. So we have to eliminate that sensor, that input. It's like I turn down the radio. Okay, now I free, right? So that's why we want to make sure that we evaluate how much overload could be there. The problem is that we don't have an instrument for that. So we had to create a kind of tool that will give us, because I cannot put people in an instrument and then it will print out the cognitive load or overload. That's not how it works. So we needed to identify what could cause cognitive overload so we can take a look and make sure that those conditions, even though they will exist because they have to exist, that they don't exist to the point that is going to create an excess in my cognition. And those are available time, which means the time that I am expected to finish my activity, okay? If I have enough time, if I have barely adequate, and so on. We have a scale, then you evaluate from 1 to 5 how much time, and select which one. I'll show you the tool in a minute. Stress, high, low, medium. Complexity and task design from 1 to 5, how complex it is based on the people that are there. Of course, we are not going to evaluate people. We are evaluating activities that people execute. Instructions, human matching interface, fitness for duty, fatigue, tiredness. All of these things have an impact. And these 10 categories are also part of studies that have been performed in the Nuclear Regulatory Commission. So what we did was, let's create a tool that at least give us an idea of how much of this could be having an impact and creating these conditions for people to have memory and attention failure. So we look at everything, and this is just an example of how much we miss when we don't know what we don't know. For example, let's say that you are going to dial a phone, and I provide you with this, with the numpad that is on the left side. Okay, that starts with 1, 2, 3. If you're going to dial a phone number, most likely you are going to be you will have to think a little bit because the context has changed. So when you take out the dialing pad in your phone, it's like the left design, and if you're doing the right design, and if you're using your calculator, it's going to be the left one. So if you're using a calculator, you better have this type of design. If you're going to be dialing a phone number, then you use this design because our brains are conditioned that way, and we switch from one to the other, and we don't even know that it's happening, and you will be surprised how many things you can detect that could potentially cause things, and we don't even know that it was this. I don't know, because what is this? It's those things that we can explain and say, you know why? Because you're changing your condition to do this way, and I'm changing it, and it'll take some time until you can figure it out, and that's consuming resources of attention. So of course you're going to have memory failures. And so try to say the alphabet and incorporate a letter that does not go in that place, and try to do it as fast as possible, and see if you don't get all confused and have to forget it. No, because it's mechanic. So and it's all based on context. So I just wanted to show you that there is so much more than meets the eye when we talk about human error. These are other, again, very old and ridiculous examples, things that can create unintentional errors of commission because they look very similar, or I have a goal and I have to do whatever it takes, creativity of people, or designs that keep us scratching our heads. Is this supposed to be here or the other way, or how? Or, I don't know. Thank you for nothing. So we do help, but then we have to take a look and see what else is happening, because people have goals, people want to be successful, they'll figure it out, and that's why we need to support and create conditions for this not to happen. Here we have seen mirror image designs, right? Stop, start, 2, 0, 1, 1, 0, 2. We have seen this so many times, and we are, and actually this is one of the reasons anesthesiologists used to make a lot of mistakes, and a lot of people say, I don't care that much about the surgery, it's the anesthesia. Well, because the equipment were not designed in the same way. That's where ISO was born. So, and standardizing. So because my brain is conditioned, and I have to avoid possible distractions while taking action, because I can choose the incorrect way to go. And we have to take a look at the environment when we are there, because when you are there, you will see that the things are not that black and white. For example, I'm documenting from my screen, but my screen is glossy, and all I can see is the lamp. So I have to actually move my head and see it on an angle, and in an angle, I thought that was a 4 or a 6 or a 9. Why? Because somebody was genius and used a glossy finish, and all I can see is the lamp. You know how many times I don't understand? Matte finish. You don't want that glare to getting in the way of us documenting or entering data, and those are things that are part of the design. And now you can say, well, you know what? For now, since we can't change it, because probably you won't be able to change it, but you know where the problem is, and then you can put barriers of defense to avoid that from happening. So that's why it's important that we walk around and then we take a look in our environment. Now, what is the tool, the other tool? This is the cognitive load tool. On this one, I wanna say something. It's kind of a disclaimer. I really recommend training specifically for this one, because it is a tool that is a little bit more subjective, quote unquote subjective, even though it's not, because if you're trained, then the subjectivity is gone. Well, not gone, but mostly gone. So what we do is that what we did was that we put here the category or dimensions, meaning this is available time, stress, complexity, and then from 1 to 5, how much of that exists. For example, we are looking for a 3. Nominal will be a 3. So you say they have enough time, then the tool will automatically assign a 3 here. Then if you have a lot of stress because it's extreme, then a 5 will come here. And if it's highly complex, then you have another 5 here. So you will continue to analyze it based on some criteria that we suggested, but this is not written on stone. A lot of people call me, can I change this? Yes, of course, because it's based on the nature of your process, but still it gives you a good idea. This part of the criteria was not a result of a study, more than data that we included for this, because the rest is all part of a study. But that criteria we put there to help make it a little bit more self-explanatory, but we really recommend that training. So what you do is that you go to the areas, you take a look at the areas, you talk to people, you use the tool based on the criteria, and then you have many data points, so you can say, you know what, they don't have enough time. That's why we're getting a lot of violations. That's why we are getting a lot of mistakes or slips. It's impossible, because when we designed it, we did not factor in that this sampling that's going to start at the beginning, middle, and end, at some point was going to meet the 15-minute one and the 16 minutes. So at this point, there is no way that that person can do all these five checks at the same moment, because they met. And we don't necessarily have that in our mind. We say, yeah, you can do that with this time. No, I can't, because there are others, so I don't have time. So forget it. It's 100% probability of making a mistake when I don't have time to finish. Right? So it'll give you a value, and then after looking at them, you will see something like this as a result, which is a box plot. Why do we use a box plot? Because the data, we want to make sure that it's not giving us false positives or false negatives. So, for example, here I have a 3.3 and 3.5, but I don't trust it. I have to go back and then now do a more specific analysis. But when you have enough information to say, you know what, the interface, they don't have enough interfaces, very simple. They can manage a little bit more complexity here to take it to the 3. Because I don't want you to be bored, but I don't want you to be stressed to the point of making you fail. So that's the reason why we like to see this, so we can demonstrate that there is a problem. Here we have a 3.8 in available time, and I know that my data was distributed in this So I know we have to go back and now probably do, in this case, we probably do recommend a time study or something that will give us an idea of how realistic are the times that in which we expect people to finish a particular activity that has certain definitions. And this one, these are things that probably will catch your eye and say, again, this is an example to illustrate extremes. Okay, this is not necessarily a real example. Usually we have very good and close brackets here, but that's the reason why we do it like this, because sometimes you can add, or sometimes they have so much time and you say, you know what, now I can incorporate another activity because they have the time. So it's not only to remove conditions but also to incorporate efficiencies, because sometimes, yes, it can be done, and or at least, or also maybe balance it or so on. So it does give you a lot of information in terms of what's happening, and this can explain a little bit about it. Okay, so that's with all of these tools and the root cause determination, but I don't want to finish without talking a little bit about motivation. And I want to say this because motivation is responsible for the quality and intensity of our execution. When you love to cook, it's going to have a lot of different results that if I cook, believe me. You don't want to, because there's a lot of hate in that activity. So what I'm trying to say is that, yes, motivation is important for quality execution. So how we make sure that people are motivated to do the right thing when we focus on the outcome being something good and positive and achieving something, a goal, for example. So, for example, I don't get motivated with what I have to do. I get motivated because I do this and there will be a result, an outcome, okay? So if I'm counting, I'm not going to stop until I'm done counting, right? So it's the outcome until everything is counted on or considered, the reconciliation or whatever. So I'm waiting for that moment in which I'm done, right? And that's what keeps the behavior. So triggers like SOPs, these type of triggers initiate the action, but the outcome is what's going to make it sustainable. And once the behavior is sustainable, it becomes a habit. And once it becomes a habit, you are removing a lot of information from your cognition, because are things that I'm doing correct without even knowing it. That's what we want to do. Now, we have to be careful, because habits can become bad if I allow people to deviate, and that's why we have to go back to the overconfidence calibration, supervisors on the floor, and enforcing the rules, okay? So triggers initiate actions and behaviors, outcomes control actions and behavior, and actions becomes habits, good or bad. Let's see how this goes, okay? So now we know that it's outcome. What are the outcomes? Well, the outcomes of me working today is to make sure that we get the 5 batches or the whatever lines clean by 4 o'clock, because that's the goal. Okay, so that's what's going to drive my behavior, because I have to finish by 4 o'clock. That's the goal. So if I have to finish, I will do whatever it takes. Okay? Now, when I want you to change your behavior, or when I want you to modify certain behaviors, I also do it this way, because I know you will follow the outcome. But outcomes are not all good. For example, I diet because I want to lose weight. So that's my outcome. But outcomes are going to motivate me to diet and to not deviate from my diet if I lose weight as soon as possible. So timing. But if it's taking too long, I don't forget it. This is not working, and I go back to. So the timing is important. Consistency. Every time I do this diet, would I have it? That's why they say guaranteed results, because consistency. Okay? And significance. I'm going to lose weight. That's why I'm motivated to do it. But if it's not, so in order to be very good outcomes, you have to make sure that these outcomes that we are doing are soon, certain, and positive. Let me see. For example, if I want to if I want to modify the behavior of people breaking the rules in gowning, let's say that people are leaving hair outside of the head cover, well, I want to make sure that people follow the rules. So I want to make sure they understand the rules. So even if they understand, sometimes it's more comfortable, or I just look better with my bangs out. But then, what are we doing? So so if we are going to, and we've used this for modification, for GMP behavior modification, what we have to do is put outcomes in favor of the good habits. So if I see that your head cover is covering everything, then I have to provide you an outcome, because what you did is the right thing to do. So I have to let you know that, and that's where the outcomes become a good tool. And this will be like another tool for behavior modification. How we would we do it? Well, we would put in place a program in which every time that I see you, wearing your gowning all correct and whatever, I would give you a note saying, you're following and then points, whatever. Because at the end of the day, what you want to trigger is the action, and you want to sustain the activity as long as possible until it becomes a habit. I'm not saying that I have to pay or give gifts to anybody to do their job. No. I'm saying that sometimes I have to use this type of activities so I can guide you through the right action, and that you can select the correct course of action because you want to achieve something. And of course, you mix it with what could go wrong, and the quality, and all of that is important, but I need to have something for me as well, especially we're changing culture. So make sure that people understand. Let's see this how it manifests in an example. Let's say that I have to make a decision whether I break the rule or I don't. I'm going to a meeting. I'm tight in the time, so I'm tempted to exceed the speed limit. So why would I do that? Well, arguments in favor are that I'm going to save time, and that's soon, that's certain, not positive. I got there, yay, right? So I'm very motivated to do this. But I could get a traffic ticket and fine, or even an accident. But even though it's soon, it's uncertain, because I don't know if I get caught, and it's negative, and I don't like to think about negative things. We are in denial with everything that is negative because we don't want to talk about it. But if we're telling me what to do to get there on time, as opposed to telling me what not to do to be late, I'm gonna have a better reaction to that outcome. So in this case, who wins? Well, it's a lot more. I see more benefit exceeding the speed limit because it's soon, it's certain, and it's positive. Cigarette smoking, having a cupcake, or eating a high cholesterol steak, all of them fall into the same category, okay? All are going to kill you at some point. So if you have high cholesterol or diabetes or so on, what I'm trying to say is these are maladaptive behaviors, and we choose to take these actions. Why? Because of motivation. What could happen? Well, I like the cupcake. So good. This is so tasty. Soon, certain, and positive. That's how we are. But then long damage is late, uncertain, and negative. It's weaker. So what I'm trying to say is make sure your outcomes are directly related to positive things, because those are a lot more stronger and will guide my behavior in a more effective way than negatives. That's why our metrics, we should change the ways our metrics are. Overdue CAPAs, overdue investigations, how many batches on hold. Well, then, of course, our metrics are based on our failures. But if we are targeting 100% release, then there is a motivation. It's like, I have to avoid pain. No, I want to be happy first, and then if I can't be happy, then I'll avoid the pain. And that's why we always talk about it. So we want to make outcomes in favor of good habits and not the bad habits that we don't say, but they are acceptable practice. We allow people to work from memory until something happens, and then we kick them and say you were not following the procedure. But that's a normal behavior, so it's an acceptable unspoken practice, okay? And then we have different range of outcomes. So the strongest are soon, certain, and positive, and the weakest are not soon, not certain, and not positive. So make sure that you present the goals in a positive way and that we can see results as fast as possible. The sooner I start seeing results, the more I will feel the motivation to continue. That's why when you start, and I use the losing weight example, but there are so many. That's why when you start losing weight, you get motivated and you continue, and then you continue. Everybody says it's the beginning. Well, of course, because you don't have results that motivate you. So you're doing this by faith. You don't know if it's going to work, and and on top of that, you're suffering. So that's how we behave, and that's how we do. Right? So I wanted to say that. And last but not least, if you want to predict, you already have the tool. Start from the bottom up. Conditions are there, and that way you can prevent situations. So the tool gives you not only the root cause, people were not following the procedure because there was no procedure. It's also telling you the CAPA, because if there is no procedure, your corrective action is to write it, and your preventive action is to make an analysis if there are other critical activities that are missing instructions. And it also tells you prediction. You want to have you're creating a new area, make sure procedures are available that are easy to obtain, and eliminate those conditions from the existence, and that way you will be very successful. Remember, we want to make sure that we do as much prediction and prevention, even though we don't like it that much because we cannot measure success there, because we cannot measure what did not happen, but it's responsible, and we owe it to our jobs and to the organization. So conclusion, if it's lack of training, train. If it's an honest mistake, coach. If it's asking the impossible, adjust expectations. If knew better, hold accountable. And that's the main message here. We have been very successful, and we know that you will as well. We have very dramatic results, and they're very repetitive. We keep having very similar results, so we know that it's effective. In this case, we started with a human error rate of 0.047, and we finished with 0.019, which is a 60% reduction in less than 10 months. And, of course, the most dramatic result is going to be at the beginning, because then you're going to fine-tune the list of your problems. But these are the biggest ones, and these are the ones that you want to tackle. So this concludes my presentation. We have a couple of minutes, or maybe a few minutes for questions. I'm gonna send it back to the moderator to capture those, and I hope I can answer and provide you with the information that you might be needing. Thank you very much.